Good afternoon, all of you. So, we were dealing with the oxidation number method to balance a redox reaction. And in that, we completed the acidic medium method. So, we will be doing one more example of acidic medium method in today's class and then move on to the basic medium method. So, acidic medium, we will see one more example. Cr2O7 2 minus SO3 2 minus gives Cr3 plus SO4 2 minus. So this is the example we are going to do today. So we will be following a stepwise procedure. So the first step to find out a balanced equation is to find out the oxidation numbers. We will be finding the oxidation numbers of individual atoms here. And we don't need to find that of chromium because for an ion, the net charge of it only is the oxidation number. So for chromium, 3 plus is its oxidation number itself. So we don't have to find of chromium. Others we will see. So in this chromium, it is not as a single ion, it is staying with the oxygen. So we need to find out the oxidation state of chromium here. So that will be oxygen will have 7 into 2, 14 minus charges, and in the net charge we have two negatives. So the totally chromium will have a 6 plus charge. So that 6 plus into 2 will become 12 positive. 12 positive minus 14 becomes 2 negative. So we found out that of chromium. Then we'll come to sulfur. Sulfur in SO3 2 minus. Oxygen we have 3 into 2 minus. So 3 into 2, 6 minus charges are there and the net charge is 2 minus. Hence sulfur will have a charge of 4 plus. So 4 plus minus 6 will become 2 negative. Chromium we have 3 plus only and sulfur again. So 4 into minus 2 charge for oxygen. So 4 into minus 2 becomes 8 minus and we have a net charge of minus 2. So hence sulfur will become 6 plus. 6 minus 8 becomes minus 2. So we found out the oxidation numbers of individual atoms. Now the step number 2 is to find out which one is oxidizing and which one is reducing. So finding oxidation and reduction. Or we are going to find out which one is oxidized and which one is reduced here. So considering chromium, chromium from 6 plus it is changing to 3 plus. So it is decrease in its oxidation number 6 plus to 3 plus. So we can tell chromium is getting reduced. So reduction of 3 electrons is happening there because 6 plus to 3 plus. And now we will see which one is oxidized. Oxygen is having same oxidation number in both the places, so we don't consider that. So sulfur from 4 plus to 6 plus. 4 plus to 6 plus, which means increase in oxidation number. So we can tell sulfur is getting oxidized. Oxidation of 2 electrons, 4 plus to 6 plus. So we have completed with the second step where we found out the oxidation and reduction. Moving on to the third step where we calculate the increase or decrease in the oxidation number per atom. So we need to check the oxidation numbers here or how much it is reduced and how much it is oxidized. So here if you see 3 electrons are reduced and 2 electrons are oxidized, there is a mismatch also. And one more thing is, here if you see 2 atoms of chromium is giving 6 plus. So here one atom of chromium is showing 3 plus. So there is a mismatch in this. So to manage all this, we are just adding one 2 over to this side. So here it was just 2. So balancing that, we'll give 2 here. So once if you are adding the number of atoms, we need to increase the number of electrons also. So two of them were involving in this. So initially when it was 1, there was 3 electrons, and when 2 of them came, we need to multiply it with 2. It will become 3 into 2. Total 6 electrons will be there for reduction. Now there are 6 electrons for reduction. We have to see the oxidation part. Oxidation is still 2 electrons. So we have to make it 6. So what we can do? Sulfur is becoming 4 plus to 6 plus. So 2 electron is changing in one atom of sulfur. So how many atoms will give us 6? 3 atoms. So both the sides we are given 3 atoms. So 1 atom of sulfur gives us change of 2 electrons. That means 3 atoms of sulfur will give 3 into 2, 6 electrons. So 3 atoms of 1 sulfur and 1 sulfur will give us change of 2 electrons. So 3 atoms will give us change of 6 electrons. Reduction also 6 electrons, oxidation also is 6 electrons. Now that is balanced. So first we check the chromium. Chromium here 2 atoms was there. So balancing that we kept 2 here. So that 2 only we multiplied with the electron number. So electron number became 6 electrons. To balance that, we gave 3 electrons, 3 atoms of sulfur in both the sides. So 1 atom of sulfur gave 2 electrons. So 3 atoms of sulfur gave 6 electrons. So 6 and 6 reduction and oxidation is balanced here. So we completed the third step here and moving on to the fourth step where we make the number of hydrogens and oxygen atoms equal in both the sides. So this is the last step of balancing where we count the number of oxygens and hydrogens in both the sides and make them equal. So first we will be checking the number of oxygens. So here 7 oxygen are there and here 3 into 3 will become 9. 9 plus 7, 16 oxygens are there in this side. So how many oxygens are there in this side? 4 into 3, 12 oxygens. So here we have 12 oxygens and here we have 16 oxygens. Here we have limitation of 4 oxygens than this side. So according to the rule which we studied yesterday, how much ever oxygens we need, so that much H2O we can add. So in acidic medium, if we want oxygen, how much ever oxygens we need, same number of H2O we can add to the same side. So this side we need 4 oxygens, so hence we are adding 4 H2O this side. So the number of oxygen becomes equal both the sides. So here it is 7 plus 9 will 16. Here it will become 4 into 3 12. 12 plus 4 will be 16. The number of oxygen is balanced. Now we need to check the number of hydrogens. So this place it is 8 hydrogens and here there is 0 hydrogens. There is no hydrogen at all. So yesterday we told that rule also. If we have lack of hydrogen atoms in any of the sites, we can adjust it with adding how much ever H plus ions we need. So as it is acidic medium, we don't have any limitation for H plus. So H plus same we are adding this side. So we need 8 H plus in this side, so that we are adding there. Now the number of atoms of hydrogen also is equal. Here also 8H is there. This place also it is 8 hydrogens. So now the equation is balanced. So this is how we balance equation in acidic medium. First step, we will find out the oxidation number. Then we will find out the oxidation and reduction. Then balance the number of oxidation and reduction numbers. Then balance the hydrogen and oxygen. That's how we do the acidic medium balancing of redox reactions. Now we will move on to the basic medium. So basic medium is very similar to that of acidic medium balancing except the last step. So we will be discussing that. We have an equation here. The same step we are repeating in the case of basic medium also. First finding the oxidation numbers. So we need to find out the oxidation number of individual atoms here. The same thing which we have done in the acidic medium. So manganese, if you see 4, 2 negative oxygen will be there. So 4 into 2, 8 minus. 8 minus and a net charge. So the manganese will be 7 plus. In bromine, we don't have to consider the oxidation number because the charge only is its oxidation number. So it will be minus 1. In this manganese, there are 2 oxygens and there is no net charge. So 2 into 2, 4 minus charges will be there. So the charge of manganese will be 4 plus. In this case, bromine, 3 oxygens are there and a net charge of negative. So 3 into 2, 6 negative charges. To balance that and to give a net charge of negative, bromine needs 5 plus. So 5 minus 6 will become 1 minus. So that's how we find the oxidation numbers. Moving on to the second step, which is finding the oxidation and reduction, which is same in that of acidic medium. So plus 7 to plus 4. Manganese is having a decrease in oxidation number, hence we can tell it is reduction. And bromine from minus 1 to plus 5, increase in oxidation number, hence we can tell it is oxidation. So in reduction, involvement of 3 electrons, oxidation, involvement of 6 electrons. So there is a mismatch in this number. Oxidation, there is 6 electrons, and reduction, there are just 3 electrons. This should be equal. The number of electrons involved in reduction should be equal to that of number of electrons involved in oxidation, because how much ever electrons are given out, the same number is accepted in a reaction. Then only it will be balanced. So this number should be equal to this number. For that, we are moving on to the next step, which is the third step. Calculate the increase or decrease in the oxidation number per atom. So hence, we know reduction is 3 electrons and oxidation is 6 electrons. To manage this, what we can do? So 3 electrons we need to increase to 6. We don't reduce electrons in any equation of balancing. We always multiply. We don't divide at all. So multiplication of 3. How much electrons we need? 6. So manganese, if we increase the number by 2, then we can have a solution for the problem. So two sides we give 2 manganese atoms. So from 3 electrons we need 6. So that's why we gave 2 atoms of manganese in both the sides. So the number of electrons reduced will become reduction of 3 electrons into 2. That will be 6. So 3 electrons per atom. 2 atoms we are providing. So 2 into 3 will become 6. So reduction is equal to 6 and even equal to oxidation number. So now we are balanced with this. And moving on to the last step. So here we have change in the acidic medium and basic medium. This is the step which we followed in the acidic medium. Make the number of hydrogen atoms in the expression on the two sides equal. Hydrogen and oxygen we considered. This step we are not doing in case of basic medium. That is just for the acidic medium. So here what we do is, in the step 4, we balance the negative charge and oxygen. So that is the difference between acidic and basic medium. So here we are balancing the negative charge and oxygen. So first we will find out number of negative charges in both the sides so that we can balance it. So here we have one negative charge here into number of compound 2. 2 into 1 will become 3. 3 plus 1 negative charge here. So totally 3 negative charges are there in this side. So hence how many negative charges are there in this side? Just 1. So 1 negative charge only is there in this side. So how we manage the negative charge? As it is basic medium, how much ever negative charges we need, we can add same number of OH minus ions into the same side. So as it is basic medium, how much ever negative charge we need, we can add the same number of negative charge to the side which we need. So here the lack of negative charge is there in this side. So if we add 2 OH minus ions, we got 2 minus ions there. So 2 minus, so totally the negative charges are balanced. Here also 3 minus charges are there. Here also 3 minus charges are there now. So 2 from here and 1 from here. Now we need to check whether the oxygen is balanced or not. So first we need to find the number of oxygens in both the sides. In this side it is 4 into 2, 8 oxygens are there. In this side we have 4 here, and here we have 3 and we have 2 here. So totally it will become 9. 9 oxygens are there in this side, and this side we have 8 oxygens. So similar to that of acidic medium, how much ever oxygen we need, same number of water we can add in any of the sides. So to balance the negative charge, we added OH minus, and now to balance the number of oxygens, we can add how much ever water molecules we want. So here we have 9 oxygens and here we have 8 oxygens. So one more oxygen is less here. So that's why we can add one more H2O to this side. So that will become 9 oxygens in both the sides. And what about hydrogen? Hydrogen we don't need to balance, it will balance automatically. So check the number of hydrogens. Here we have 2 and here also we have 2. So in basic or basic medium, we don't have to balance hydrogen, it will balance by itself. So this is the final balanced equation what we have. The same step what we have done in the acidic medium we are repeating until the last step. And last step we are balancing the negative charge and then the number of oxygen atoms. And hence we get a balanced equation here. So that's all about balancing a redox reaction with oxidation number method. So with this we wind up the class and you do have a work to do. You have to balance the equation, this equation in basic medium. So write this and complete the notes and submit. Thank you.